Hi, everyone. Welcome to our event. This event is brought to you by DataTalks.Club, which is a community of people who love data. And today we have an interview with Simon, right? Did I pronounce your name correctly?
Yes,
Simon.
that's fine.
And how do you actually pronounce it?
Well, in German, you would say Simon. Also,
Simon.
I think in Dutch, even since I live in the Netherlands, also in Dutch, I think you would say Simon. But typically to my English-speaking friends, I say, call me Simon or whatever fits. I don't mind.
So you say Simon, but then in German it would be Simon.
Simon. Yeah.
Simon. Okay. I'll try my best to do that. So today we have Simon. And yeah, so during the interview, you can ask any question you want. There is a pinned link in the live chat. Click on that link, ask your question, and we will be covering these questions during the interview. And now I want to open the document we prepared, document with questions for you. Okay, I don't know if you have it ready.
I have it ready, yes.
Opened it. And, okay. And yeah, I think if you're ready, we can start.
Let's kick it off.
Yeah. This week we'll talk about MLOps and building machine learning platforms. And we have a special guest today, Simon. Simon has been building ML platforms for over half a decade. Currently, he is a lead MLOps engineer at Transaction Monitoring Netherlands, TMNL. I was always wondering what this stands for, TMNL. Now I know. So, which is a worldwide unique initiative of the big five banks of the Netherlands. And next to his work at TMNL, Simon is also a university lecturer for data mining and data warehousing. So welcome to our event.
Thanks a lot. Thanks for having me.
So before we go into our main topic of MLOps and ML platforms, let's start with your background. Can you tell us about your career journey so far?
Yeah. So actually, I started out my career as, well, doing a PhD, being a research and teaching associate, actually, at Vienna University of Economics and Business. And there I was doing some research in the area more of computational advertising. So always machine learning applied to problems in the space of online advertising. Well, I wasn't a PhD student for that long because, well, in the end, I found some very interesting challenges in practice. So I became a data scientist and worked for a consulting company in Vienna for quite some time. Started off as a data scientist. I worked on a lot of interesting industrial AI use cases, visual inspection, predictive maintenance, all these classics. And then step by step, well, we also started to develop back then, and this is also kind of how my MLOps journey started. We started developing a deployment and serving platform for our models that we built for our clients, simply because we actually thought we found that this back then was a significant blocker when it comes to actually creating value with your machine learning models. And that's also pretty much how my journey in the MLOps world started. Back then, at least we were not aware of the name MLOps yet. We called
Nobody
stuff,
was.
well, yeah, deployment and serving platform. Already that sounded way too cutting edge for many companies we were dealing with. Well, after working consulting, I moved to the Netherlands and where I'm still living. And there I joined bol.com, which is the largest e-commerce company here in Belgium and the Netherlands. I think even still larger than Amazon, although Amazon also entered the market, I think 2 years ago. There I was a expert machine learning engineer, so kind of a staff engineer for machine learning. And we dealt a lot with natural language processing, trying to understand our customers, built some transformer models, working on the GCP and Kubernetes. After that, I changed to where I'm still at now, TMNL, Transaction Monitoring Netherlands. Here I am the lead engineer for machine learning operations. Actually, to be very accurate, I used to be the lead engineer for MLOps until 2 weeks ago. Now my official title is Manager Engineering and Development. Bit of a different thing. MLOps is really, really still very close to my heart, but the focus in my daily work has shifted a bit. Now
You're a manager
more focused on the effectiveness and collaboration of various tech teams.
Which is also actually a part of MLOps. Maybe we can also talk what MLOps is, what is not. I'm really interested to hear your take on that. Because for me, MLOps is not only about the tools you use for deployment, right? There is much more. So
Correct.
So maybe we can talk about this right now. So what, in your opinion, MLOps is? So 5 years ago, you said you had no idea that this thing you were doing called MLOps, you just called it deployment. But right now, MLOps is more than that, right? So what is it?
Yeah, I fully agree. So it's typically when you hear the term MLOps, when people hear the term MLOps, always what pops up in the brain is feature stories, experiment trackers, model registries. That's what comes up, and that definitely is one part of MLOps. It's the tooling part, more the tech part, I guess. But at least I believe that doing machine learning operations successfully is a lot more than the tech part. It's actually the classic thing. It's about people, process, and technology. Technology part, okay, feature stores, model registries, these pieces, that is what people are typically familiar with. But introducing machine learning operations successfully is a lot more than that. It requires processes, understanding how models are developed, how models will be developed, what are actually the use cases, the requirements, what do we need to fulfill. This is actually where MLOps starts, understanding the processes behind model development, deployment, and serving. Because in the end, the tech part of MLOps is all about streamlining and automating exactly these processes. Of course, the third part is then people. That is machine learning operations is still a fairly novel realm, and a lot of companies do have the challenge to think a bit what skills do we actually need? What does it mean to build? What does MLOps mean? And that might also mean something different for every company. But what skills do we need to build a machine learning platform? What do we need to bring a model to production, to bring 100 models to production and to operate them? It's really a lot about people as well, people in terms of skills, but also people in terms of how they collaborate. Yeah. So MLOps is a lot more than the tech part.
Yeah. Because like to me, when I heard MLOps for the first time, I thought, okay, I've been doing this thing for so much time. But in my mind, it was mostly deployment. So, and I think like you, I followed kind of similar path. So I started as a data scientist, and then I noticed how difficult it is to deploy models. So it's a significant blocker in the process of productionizing ML models. And then we were not really building a platform for doing this, but we were thinking like how exactly we can make it simpler, right? And then I thought, when the term MLOps came, I thought, okay, like I'm such an experienced MLOps person. I was doing this before, it was cool. But then I started learning more about this, and then there are things like feature store. I had no idea what that was, or like experiment tracking. Like I understood that this thing that we used was actually an experiments. And so there is much more. But then, like you said, in addition to technologies, there are also people and processes. And one thing you brought up was what skills we need to build a platform to serve hundreds of models. Did you find an answer to this question, or you're still looking?
In principle, it's a difficult one because it very much depends on the general organizational setup and fundamental beliefs of some organizations. At least in my world, and that's typically also the world I select, I believe in principle, end-to-end responsible teams for shipping products. So that means in my world, what I believe works well is the building, the deployment, and the serving itself being in the hands of what I call stream-aligned teams that actually with their products create value for that organization. A platform then, I consider it on the one hand as a way to streamline processes, how these stream-aligned teams, these teams actually working on ML-powered products, how they develop it, how they develop their models, deploy them, and serve them. So it's about building a platform to streamline their processes, but also to make their processes faster, to make them worry about less, reduce the cognitive load on these teams. So when you think about building this platform, which is then really not about actually developing a model, then typically the skills that I saw to be incredibly valuable is this mix of infrastructure and cloud knowledge. Because these days, in most organizations, many organizations, you do build your platforms, your products in some kind, in whatever cloud, whether it's AWS, GCP, Azure, whatever. So definitely the infrastructure and cloud knowledge is something that is incredibly important for building an ML platform.
Like things like Kubernetes, that sort of thing.
Terraform, knowledge of, let's say, AWS services and how they can help you build what you want to build. Then also next to the infrastructure knowledge, it's really knowing how models are built. So knowing your users, actually, your customers, because as an ML platform team, your customers, your users are typically internal data science teams, or at least product teams with some element of data science in them. So actually having an understanding for them is quite fundamental.
But do you mean that a platform engineer needs to know what is, I don't know, finding a derivative in the functional space?
No,
means
not at all.
Or
That's
like
definitely
that XGBoost exists and whatever it is,
yes.
this is a model
I
that
think, yeah.
outputs some numbers.
Yeah, so pretty much the latter. So
Okay.
I believe as a successful ML platform engineer or MLOps engineer, I sometimes call them, you have to know the data science workflow. How do data scientists actually work? You need to have an understanding that, yes, data science is an experimental discipline as well. There needs to be space and support, tooling support, process support for doing experimentations, for example. All these are things that if you come from a classic software engineering background, typically, this is something you have not quite seen, or you don't quite understand why somebody would work in a notebook, right? It's typically like,
yeah. So for me, it was the first reaction when I saw Jupyter Notebook.
Yeah.
So I was a Java developer, and then somebody showed me a Jupyter Notebook and said, "Okay, this is how we do things," and I'm like, "Oh my god, really?"
Yeah. Yeah.
Where's my so I used back then Eclipse, this IDE,
Yeah.
and like, where's my IDE? Like, what is this?
Yeah.
It's like it's awful.
Yeah.
But yeah.
Yeah, as an ML platform engineer, well, you need to understand why people actually choose that and how this.
Why would
how
you
this
program in
augments
a
their workflow.
browser, right?
Yeah. Yeah. So understanding your users, understanding how models should be deployed, what deployment patterns exist. These things matter. What does not matter for an ML platform engineer typically is what you said. I don't know why I would choose a root mean squared error over a mean squared error. That for an ML platform engineer is not quite important. It's important to understand there are certain evaluation metrics, perhaps on that level. Yeah, because
so
in the end,
these metrics exist, but I don't really need to know what is the difference between mean average, what is my mean average error, right, versus something else.
Yeah, exactly. At least that level of knowledge should be sufficient to build tools that help your data scientists do things more effectively. Of course, the deeper your knowledge, always the better. But well, there are hardly any unicorns, right? So you need to prioritize a bit. Typically, these two things are important. And the third thing is then more well, obviously, in some way, you need to write your next to writing Terraform. You also will need to write some Python, for example. You will need to perhaps write some Java, depending on your context. So the classic software engineering part also is of importance.
So infrastructure and cloud, first thing, then knowing about the process of building models, the second thing. You do not need to know in details, but you need to know how the process starts, what are the things that data scientists do, and what is the output, right? That's the second thing.
Yeah.
And then the third thing is being a software engineer.
Correct. Yeah.
And how important each of these things. So like if you order them in terms of importance, what's the most important one and what's the least important one?
Good question. So in principle, dodging a bit the question, I always believe in a team needs to have the sum of the skills in a team.
Okay.
That needs to be right. So in a team, you might have specialists who really have a big strength on the cloud engineering end. And for them, for example, that's what they would add to the team. And they might have close to zero knowledge of how models are built. And that is okay if there is another person who can augment that. But if I had to now rank them for one person, I would say infrastructure knowledge number one, software engineering knowledge number two, understanding of how data scientists actually work number three. Also because I believe that's probably the thing that you can catch up the easiest. And also your users, your customers will let you know, hopefully, when you build stuff that just doesn't work for them.
Or have a data scientist on the team, somebody
Or that, exactly.
who was a data scientist, but now is more interested, let's say, I don't know, in software engineering or platform engineering.
Exactly. That's what we
Then
typically try to aim for. Also in at TMNL currently, in the machine learning operations team, who are building the ML platform. That's also what we have been seeing as really, really effective, bringing a mix of specialists and a bit generalists together. Some specialists on the cloud engineering end, infrastructure end, some people who have been data scientists and over the time transitioned. Typically, the sum of these parts really makes a good ML platform team.
How many people should there be? Like at least 2, 3, or?
Well, it depends a bit on your availability requirements of the platform. So, for example, if you need to have people on standby and so on, then you need to factor that in.
You mean like if we want to make sure that this platform is up and running all the time, then somebody will need to have to be, how do you call it, on
call,
pager, on call, yeah. And then like if something happens during the night, they would get notified, and then they would wake up and fix the thing, right? And then one person cannot do this. Like there should be at least 3,
absolutely.
right?
Even 2 people cannot really do this. So it really depends on the load on your platform, how many teams and people use it, how business critical is it actually. That I think defines a lot of the real headcount requirements. If you just think about building it, let's ignore any significant operational overhead that comes from just having it up and running 24/7. 4 people, 5 people, 6 people are typically nice numbers for an engineering team, where you can also have a nice mix of skills. But it's difficult to answer, depends.
At what point should I actually think about building? Because like, let's say 6 people, especially now when everyone's budgets are kind of tight. Does it actually make sense to, build a team with 6 people while they can be doing something else? Maybe it's a good idea just to buy an existing platform. Like there are quite a few on the market, right?
Absolutely. So there is always, I think these days, there are not many companies who make and should make the choice to build a platform, an ML platform from scratch. I think usually what companies look into, companies that are not Uber, right? That are not Amazon, and these big tech companies. Typically, what normal companies look into is how do we buy from vendors, tools from vendors, and how do we integrate them in our landscape, and how do we make them work together? So usually it is more what do I buy, and maybe some parts you build yourself. But even if you buy platforms or parts of platforms, there is a lot of integration effort, gluing things together, making it fit to your workflows, because these might be very different depending on your organization, depending on your use cases. So even if people advertise end-to-end platforms, you can be quite sure that you will either need to adapt your processes, or you will just need to, bend, glue some things to actually make it work for you. But to your original question, maybe when you should start building a platform. Typically, there are a few smells that you see, and which give a bit of an indication that you should consider thinking about a platform. For example, you have a set of engineering teams that have data science somewhere in their products. Let's say you have 5 or 10 teams, and a couple of these teams make products that are powered by some model. Let's say a team that takes care of some recommendation engine, a team that takes care of some natural language processing. Right. Also thinking now a bit about my e-commerce experience. If you then see these teams reinventing the wheel and doing training, serving, all of these things in different ways without actually having a really, really good reason, that's usually the point where you should think about, maybe a platform that helps me standardize some things and take away rebuilding of these things. That could then definitely make sense. And typically then you can also calculate the business case and see, does it pay off or not?
And one thing you mentioned that teams do things in a different way, and teams is plural here. It means that you have to have at least multiple teams in your organization, right? In order for them to do things differently. Because like maybe if you're a smaller company, maybe just have one team.
Yeah, I think in that case, it doesn't mean that you should not consider a platform, because even for one team, at least some elements of a platform, for example, an experiment tracker, which is typically one piece of a larger platform when you build or procure it. That is something that is can be super important and a massive boost in effectiveness, even for one team. And these things, especially if you go for some isolated pieces, typically there are SaaS offerings. You do not need to worry about any maintenance whatsoever. That is something that comes with very, very little overhead. Engineering overhead does cost something, obviously, but these are things that you should consider in any case, even if you have one team building things. When I talk about platforms, typically in my mind, it's more comprehensive software and infrastructure that helps you do what you want, but at scale.
And one thing we talked about was processes. So, right, we talked about skills that people need to have, but he also mentioned processes. And actually, one of the skills is understanding these processes, understanding how data scientists build models. And another thing you mentioned is if you use an external platform, for example, for doing that external ML platform, the flow they have, the process they had in mind when building this external platform might not be the same as the processes you have, right? And then you would need to readjust, to redo your projects in a way that fit this platform. And so the processes here seem to be quite, it seems to be quite an important part. So I'm wondering what these processes are. Maybe can you walk us through a simple process?
Yeah. Simple process. So as a simple process, usually the data science workflow starts with pulling data. That's typically where the work of a data scientist starts. Let's say you want to do some exploration because you want to start building a new model. You want to train a new model. That your process, your workflow would start with pulling data into a exploratory environment, into a notebook, for example. That's usually where it starts. So then you go on to, well, perhaps you need a cluster to actually do proper experimentation on that data set. Well, again, a branch of your process will be, well, you have the need for actually a bit more powerful, scalable compute environment in an exploratory setting. Part of your process, right? It's starting to branch off. Then you would train something, you need to evaluate it. You want to keep track of your experiments. That would be also a piece of your process, something that your platform should help you to do, that it should cater to, keeping track of your experiments, of your model training and evaluations. Then you want to, as a next step, you want to persist that model and perhaps share it as well, make it available to services, to downstream processes. Now you need a model registry for that, right? Then the story goes on. How is that model going to be consumed by a downstream service? Does it even need to be consumed? Is it maybe only a batch job that actually runs this model? All these that's when we speak about processes, that's exactly it. Depending on your use case, depending on how your people build these models, that process will look different, and you might have several processes depending on your team and your use cases again. So when I say you need to understand your process to build a platform, to think about tooling even, this is exactly it. You need to understand how are data science products built in your company.
So for example, if most of our projects, like 70, 80% of the projects, ML projects, they don't need to be up and running all the time. We just execute them in batch. Then maybe we do not need to invest a lot of time in making like a platform that can serve these models online.
Exactly.
We should focus first on batch, right?
Exactly. That can be I think what you said is already a bit one step further, prioritization, right? Because you could build this beautiful platform that does it all and serves every single thing that you might want to do. But exactly, that's not how you typically build. You want to build iteratively, incrementally, also when you build your platform. So you need to prioritize. And if you see, as you said, 70% of your models, and let's say the value that these models generate is equivalent to the quantity, that's typically what you want to build out first.
It's also important if you decide which platform to buy, because maybe not all the platforms support batch. Because I know I definitely saw a couple that do not support batch mode. They only support online, like web services. And then like I was like, do I really need this? It's like, it's not really what I want. And some of these platforms, they offer batch in air quotes, which is just sending a lot of requests to the online service.
Yeah, that's a good one.
Then you think, okay, like, do I really need that, or maybe I need something else?
Yeah, it's a very good point. Even thinking of Amazon SageMaker, very popular service, especially for companies who are in AWS. The way that batch processing is recommended is pretty much what you said. It's they call it batch transform. So what it does, it spins up an endpoint, shoots, let's say, your complete batch run against it, and that, right, in batches you often deal with large amounts of data. Shoots 100 gigabytes of data against it, and then it tears down the endpoint again, and that's batch mode. It's actually spinning up an endpoint, tearing it down. Whether that's really what you want and whether that is cost effective for you, and whether the performance is this is optimum from a performance perspective is questionable, of course. That's what you really need to look into. So very good point that you made.
It's like on paper they have batch transform, right? But like when you start looking into this, like maybe it's not what I need. So like, and it comes back to the second skill set of skills that you mentioned. Like you need to understand the process, like how exactly models are built, in order to understand that, okay, this actually makes the difference. Like if I want my batch jobs to be fast, then this platform does not work for me. And I need to do something else. Maybe I need to build my own stuff with Spark or whatever.
Yeah.
Right.
Yeah.
Let's see.
Absolutely. And that might not be then the killer argument not to go for that platform, but there you will need to build something custom or a different route, perhaps.
And
or
then
you need to bend it. That's what, for example, at TMNL we are heavily using SageMaker as well. Well, I need to bend some things and find other ways how to do batch processing without using batch transform. But also that bites you a bit, because in that specific case, if you followed the recommended path, then you would get some nice features down the line still, some automated bias and fairness detection out of the box. Clarify, they call it. That's what you do not get, or the integration is just so much harder if you go for the non-batch transform, a way where you don't spin up an endpoint, shoot your data against it, and tear it down again. Yeah. So there are downsides to then having to branch off and build your custom stuff.
Okay, so then to summarize, the process is first exploration phase, where you need to pull some data, and for that you need a platform, like a data processing platform, I guess, where you can do things, explore things quickly. Could be like, I don't know, a data warehouse, or I don't know, a Spark cluster. Right?
Could be let's say you're on a GCP, you have BigQuery, and then you have some Colab notebook, and you authenticate to BigQuery, pull in, write your SQL query, the notebook, pull in your data. That would be an exploratory setup. Of course, you want to have enough infrastructure power behind your notebook so that you can actually do what you want to do usually.
I think Databricks also.
Yeah.
Databricks also offers this kind of stuff, right?
Yeah,
I know it's based on Spark, but
Databricks, AWS has it. I think pretty much all the big cloud vendors. The platform component about that is really giving your data scientists the ability to provision the resources that they need to do their job. So obviously, as a data scientist, you don't want to then configure and spin up via infrastructure as code your own cluster. But what you want to do is you want to click some buttons to spin up your cluster and connect to it. And this is really the platform part, making it easy for people to do their work.
So they don't need to, I don't know, clone a Terraform repo, create an EMR cluster there, wait for some platform engineer to approve this, and then apply the plan, and then maybe
you want to build a self-service capability so that it's easy for people and they don't need to worry about infrastructure as code and these things.
Okay, so that's data exploration. part, right? Where we pull the data, we explore, and we see what we actually can do with this data. The second step is once we did the initial exploration, we train and evaluate models. And then you mentioned that we need experiment tracking tools, right? So that's another set of tools or another tool that we need in addition to the first one, right?
Yeah, I think an experiment tracker is something that most teams, specifically teams that at least use some evaluation metric to evaluate their models, could benefit from a lot. It's usually one of these low-hanging fruits, just to move from keeping track of your experiments in an Excel sheet to actually something that, well, that works, that's scalable and also shared and transparent to your team at least.
Then the next thing is persisting the model, making it available for downstream usage. And you mentioned that we need a thing called model registry. And I know that experiment tracking and model registry is tools, they usually, like it's the same tool, like for example, MLflow, right? Or
very often goes hand in hand.
I don't know, weights and biases, or like many platforms also on AWS, SageMaker has it, GCP, I'm sure they also have it. Azure have it, right?
Yeah, it very often comes in a package, actually, especially experiment tracker, model registry, metadata store, metadata tracker and store. That is something that when you look at MLOps tooling vendors, it's something that you very often see packaged in one SaaS offering.
So, and then we kind of finish the training phase, and then we go to the deployment phase. We need to make sure that the model, somebody can consume the output of this model, and then we talk about deployment. Like we need to understand if we want to serve this online thing as a web service, or it should be like a batch job. And we talked also a bit about the tools. You mentioned it's possible to do with SageMaker. I think I brought up Spark, right? So there are a bunch of tools like that. So after that, after deployment, there is something else, right? It's not the end of the process yet.
Yeah, I think even deployment, typically when you depends a bit on how opinionated you want to be as an ML platform. That's also a piece that you could build and you should consider building for your teams. Reusable, centralized, managed deployment pipelines, especially if you have some narrow use cases. Let's say 2 or 3 use cases that you do very, very often, where the pattern that the models follow are pretty much the same, then you should even consider building and managing centralized deployment pipelines. So even that is something that you could take away from your data science focused teams. Not always a good thing, doesn't always make sense. It's something to always carefully weigh between flexibility in the teams and what you as a platform push out. That could be something. After deployment, well, it's about serving, and serving the principal decision is always, well, is it batch? Am I just gonna load the model in some batch job, in some, let's say, Spark job, do some pre-processing and run it and store my predictions in some table, for example? That's an option. I think there it's usually not so different from your training infrastructure. Typically, you would choose some workflow orchestrator, Airflow, SageMaker pipelines, then if you want to be in that ecosystem. Typically similar tooling choice, at least, as you would also do for training when it comes to orchestrating what you actually want to do. And in the end, a batch job, performing model inference in a batch job is not that different versus model training in a batch job. It's usually a sequence of jobs: data loading, pre-processing, feature engineering, training / inference. And then just your output artifacts are different. On the one hand, you have a model as an output artifact and you would store it in the model registry, whereas in the batch inference job, you would have data, usually predictions, whatever, as outputs and store it somewhere.
And when we talk about building a platform, do we actually mean that, okay, let's create an experiment tracker from scratch, or let's create a serving infrastructure from scratch, I don't know, based on Flask or whatever? Or here we mean more like, okay, what are the tools that are available there? Let's see how we can take these tools, see if these tools fit whatever requirements we have, and how we can stitch together these tools into something meaningful end-to-end.
Yeah, the latter. So again, the format, at least I could really not think of a reason why you would build your own experiment tracker. I am certain there are good reasons in some very, very niche use cases. But these tools have become a bit of a commodity even.
Mhm.
There are lots of these tools out there, from open source to self-hosted open source solutions to SaaS, fully managed SaaS solutions, pretty much everything you can think of. So I think there are very little reasons why you would really build that experiment tracker still yourself. Usually it's really about getting the right tools and integrating them and making them easily consumable and fit to your data science workflow.
It sounds like it's not a difficult job, but I think actually it is the opposite, right?
Yeah,
because like you still need to connect these tools somehow and make this seamless experience.
I think it's a common misconception people have when they think, well, such an ML platform, I mean, I'm just going to buy SageMaker or I'm just going to buy Vertex AI. Yeah, it's not so easy. Usually, well, buying it's very easy. The companies are happily going to take your money and give you access to their compute infrastructure. But again, as you mentioned, the devil is then really in, does this really support what I want to do? Does it support what I want to do given certain constraints that most companies have? Constraints meaning data governance, meaning security, meaning specific types of models, right? When you think nowadays, when you think about large language models, for example, it's not trivial to fit some special needs of large language models into existing ML platforms. And I think what you can see specifically based on this, what you could see in the last 1 or 2 months, so many vendors in the MLOps space have pushed out really, really nice updates to their platforms, to their tools that would allow you better handling of large language models. And large language models now is one example. Usually as an organization, you would have just some niche, some weird stuff that's not default and therefore not as easily and nicely supported. Or another thing is that specifically we are investing a lot of time and energy in these days is improving developer experience. It's not nice for a data scientist to interact with raw Amazon SageMaker. It's a lot of overhead. You need to think about VPCs. You need to think about encryption and these things. You should not need to think about this as a data scientist.
Yeah, sometimes I really question the design choices the SageMaker team made at some point.
Yes.
Like, why would I need a Lambda in front of an SageMaker endpoint? That's why would I send the CSV data there in my request instead of JSON? Like, and things like that. Okay. It's really, some things they look pretty arbitrary. Right?
Yeah.
Then like, it's not something data scientists will use it then. So you need to make some tooling around that to make it easier to use.
Yeah, that just takes away the unnecessary complexity and introduces some opinionated things. For example, if we want data scientists to use a specific KMS key to encrypt their data at rest, well, this is something that you would abstract away completely in a thin layer on top of SageMaker, for example, and data scientists don't need to worry. They just can be sure that their data will be appropriately encrypted.
Mm-hmm. Then you said thin layer. How thin this layer is? Is it something one developer can do in 1 week, or it's something that you need a team and work on this for half a year?
So specifically, the example that I gave now is something,
or just in general, like tooling around an existing platform.
So I believe that the layers around an existing platform, they should be as thin as necessary, so as thin as possible. That means it always depends on what you really want to achieve. So there is one side where you basically say, I want my models to be built independent of whatever they are running on. Meaning, if I want to migrate from SageMaker to Vertex AI, for example, I do not want to have to change my models, but I'm going to change the platform piece. I'm going to change the interaction patterns with these models. So if you want to achieve that, then your platform will naturally need to be a tad thicker compared to when you just say, well, I trust that we are going to stay on SageMaker for many, many years to come. And what I want to do is improving the developer experience. Then a fairly thin layer, something that is really a matter of months to develop, can be sufficient.
A matter of months. So it's still not it's not like you buy SageMaker platform and you're good to go. You still need to put in some effort before it's usable.
I would definitely say so. Again, always depends on your company, and I might also be quite biased because currently I'm in the fintech space, and when it comes to financial stuff, right, there are a lot of regulations. There are fairly strong and for a good reason requirements and everything that's security, compliance, auditability related. That of course raises the bar significantly. If you deal with, let's say, some IoT generated data, machine data, where, you know, if you lose that data, well, you've lost that data, but no person is affected whatsoever, then you might have a lot less restrictions, a lot less requirements on many things. That will naturally translate to different choices when building your platform.
Because you also worked in algorithmic advertising, right? And you also worked in e-commerce.
Yeah.
I guess the requirements there are less strict compared to fintech.
Depends on the use case as well. So even in e-commerce, you can have quite sensitive use cases. Think of fraud detection,
like
for example.
Data. Okay.
Exactly, customer data, fraud detection. If you detect a case of fraud and you ban a person from your platform, well, you need to be able to show why did this happen. You need to basically be auditable, right? So that means you need to show for a certain period of time exactly why this decision was made and what happened. And there are certain requirements typically around being able to explain your model, being able to ensure your model is not biased and that it's fair. And that can even in e-commerce with sensitive use cases, even there, that's gonna be more challenging. However, if this is a fraction of your use cases, which it probably is in e-commerce, then you would probably not build your platform for that. You would build your platform for the 90% of use cases.
So what to do with these cases, with data governance, with security, with auditability? I don't know how much SageMaker offers with this regard. So I guess you still need, especially for a bank, still need to build something on your own, right? Or there are actually tools that you can just take and adapt to your use case.
Yeah, I think so. Especially for SageMaker, it makes a lot of things definitely easier. So just thinking of emitting and storing of metadata, what specific image your job used, what inputs it consumed, what outputs it wrote. It makes tracking of these things and storing it persistently as well and connecting your metadata over various pipeline runs. It makes it fairly easy. There's still some glue code to be written if you want to be able to, let's say, visualize that or have it nicely connected in a kind of data model. Well, then you still need to do a lot of glue work. Also, when it comes to reproducibility, actually, let's say you want to reproduce the results of a model that you ran 3 years ago. Yeah, in theory, of course, your model is stored in the model registry and it's going to stay there for a couple of years if you don't delete it. But what about all the other
code
stuff?
is there and you know exactly which version of the code was used to create this model, right? And you can go back in time and
which version of the data was used 3 years ago. Yeah. So it's right. Yeah, SageMaker does help you for some things, but you need to think this process through end to end and make sure that this works. And that's what SageMaker doesn't do for you.
Yeah. What actually is data governance when we talk about this specific case, when we talk about ML platforms? Because data governance is a very large topic, and we already had like a couple of podcast episodes about that. When it comes to ML platform, is there any specific part of the data governance framework that is most important for platform engineers?
That's a good question. So usually when you look at MLOps tooling, the first touch point you typically have with consuming data from a data warehouse, data lakehouse, whatever, is that tools such as, just going to name a few, weights and biases, Neptune, Comet ML, they usually have some sort of data tracking functionality included. So meaning, and that what that means is actually fairly different depending on the tool. So some tools really focus on logging, storing metadata around your query, for example. What was the query you used to fetch data? Whereas some other tools go even beyond that, and they say, well, basically you log the entire artifact. And with artifact, I mean the data you actually used. And that means basically you would say, well, I want to store that artifact, all the data that I consume for a specific model run, I want to store it in some other cloud storage provisioned by that vendor, for example, or cloud storage that I have, some S3 bucket, for example. That's typically where it starts. So there are already different approaches are emerging in how you actually keep track of your data.
Because I think if you use MLflow, then you kind of need to arrive at the need of storing the data yourself. So you would put the data to S3, and then maybe you would keep a pointer to this data. Right?
Yes.
While in tools, weights and biases, I think that's this feature. I'm not sure about others. Probably they also do. You can just log the entire. Yeah, they all of them help. You can just say, okay, this is the data. Keep it, right? You don't need to implement it yourself.
Exactly. And that is, and one is pretty cool if you're dealing with smaller data sets. Completely fine, right? You're just going to copy that, I don't know, 10, 15, 100 megabyte data set. Well, if your models run on tens, hundreds of gigabytes of data, this actually becomes difficult to use. And not only difficult to use because obviously it's cost, right? Especially if you're using some proprietary storage of that vendor, if you don't want to upload like 50 gigabytes of data every time you train your model, that hurts. But not only that, but also managing that data appropriately becomes a challenge. Because
so what if it could be personal data, right?
Exactly. What if a GDPR request comes and that you need to delete a specific person from your data? Well, good luck to do this. If you log all your data every time you train a model, it's going to be extremely hard to find that person and reliably delete it. So you really need to think about how do you manage your data to be compliant with certain regulations as well, especially if you do things like logging your entire duplicating basically your data set every time you run your model.
Interesting. We have a couple of questions, and the first question is like chicken and egg kind of question. So the question is, sometimes I encounter problems when trying to build a whole pipeline from scratch with no models built yet. So how do you deal with drafting the infrastructure? And do you even need, and maybe this is a continuation from me, like, do you even need to think about building the platform before building the model? What should come first?
Yeah, so good question. I believe there always, especially if you want to do this in a profit-oriented organization, there needs to be a business case first. I think there are hardly any organizations who would say, yes, please build that platform, because at some point, we're going to build some models. It's typically very hard. It's beautiful if you can do this because it's a full greenfield project and it's going to be a lot of fun, but it's very hard to argue usually. So usually how it goes is you would have a set of models already running, generating some kind of business value. And then you would look at what would it have saved us on the one hand if we had a platform, and you want to look a bit into the future. How many models do we actually expect to have in a year, in 2 years, in 5 years? And what will this mean if we don't build a platform? Are we actually scalable in our efforts? So that's usually how you would start thinking about the platform. But usually models come first. Otherwise, it's going to be difficult to argue. And also difficult to build, actually.
Because it's the business case.
Yeah.
Right? Can we do this in parallel? Like, can we? So, for example, we just started the data science initiative in our company. We know that we will have a lot of use cases in the future, and there is one business case that we selected as the most promising one. Do we need to maybe start building the platform in parallel to the case, or first develop the case, develop the model, and see how to deploy to start building the platform for this specific case?
I think there are some pieces of a platform that already make a lot of sense with one model. I mentioned it before, experiment tracker is a classic thing. That is something I think no matter what size you are, that's going to pay off, even for a single model or for a single team. There are parts of, so that is definitely something that I believe you should consider at least if you have a couple of data scientists, that will make sense. There are other parts of a platform where it's going to be very difficult to build the platform in a targeted way if you do not have a good picture of what it should cater to. It's basically trying to build a product, but you don't really know your customer yet, or your customer doesn't even know himself yet. He doesn't even know, what am I going to want? I know that now I need to, I don't know, open this door, but whether tomorrow I maybe need to close it again, I don't know yet. So usually you would want to have at least a user, a customer, or a customer base that kind of knows which use cases are coming up. That's what, so you can build an architect around it. If you don't have anything, then it's a lot about guessing, estimating what's going to come. Can work, but you might be building things that are really just not going to bring that much value to your customer, or they're just never going to be used. And I think every person who builds a platform has experienced this, thinking way too far ahead, and you're building something that's going to maybe be used 2 years or 3 years down the line.
So the summary would be here to wait with heavily investing to the platform before you have at least a handful of use cases, right? And then you see
Correct.
what's common in these use cases. How can you abstract away some stuff from there?
Absolutely.
To the platform.
Yeah. And absolutely, I think that's very, very well summarized. Naturally, it does not mean that you should not build abstraction, right? So if it makes your life easier as a team, if you build some abstraction on top of SageMaker, well, do it, right? If it makes the life of 3 data scientists easier, do it. You may call it a platform, and it may be just the starting point, actually, of something bigger.
Yeah, thank you. Another question. It seems that MLOps is biased more towards software engineering. Do we still need to invest time to learn state-of-the-art models, or we just take whatever is there, like whatever Hugging Face and other framework offer, and not bother with learning SOTA?
Ooh, that's a good question. So if I understand it right, what you're saying is there are quite some Hugging Face as a model platform, also kind of a vendor, a service provider that make your life fairly easy already. So the question, as far as I understand it, is, do we even need to worry that much about MLOps itself if there are some,
or maybe
vendors?
The question is like, do we need to worry about learning about these models, the internals of these models?
Okay. Yeah.
It's because we can just take whatever Hugging Face offers, right? And then
now I understand.
As a platform team, maybe we don't even need to worry. But like maybe as a larger organization, some teams might want to learn more about state-of-the-art things, and then how does it affect our job as platform engineers?
I think it's definitely a good point. I think from for a ML platform engineer, for an MLOps person who builds a platform, it's not really going to matter whether, often it's not going to matter which exact type of model you want to run. However, there are definitely cases where this matters. Again, I'm going to fall back to the example of large language models. If your models reach an extent or are in a way that place specific requirements on your platform, on your infrastructure, for example, or on your deployment flow or on your evaluation flow, especially interesting for large language models again, then definitely you as a platform engineer, you should think about these aspects. You should think not necessarily, not about how does this model exactly work, but really would this model run on my platform actually, and why would it not? That will help you evolve your platform into directions that make it potentially future-proof if these use cases will become relevant for your organization.
Okay, thank you. Another question: how important is API design for MLOps?
API design is it depends a bit again on what you want to run. It is from an ML platform perspective, depends a bit. how if you want to abstract that away, I think where it's definitely important is for the team who wants to deploy this model and needs to serve predictions to a set of consumers. Then you as that team need to think about that, what that API should look like, and how would you evolve it over time as well. From a platform perspective, and there it depends a bit. It's, I would say, not something that you typically care about that much as a platform. As a producer of data, and teams that build and deploy and serve models, they are producers of data. They should worry about, how do I make and keep this consumable? As a platform, I would think about, how do I make it easy to deploy it and serve it via an API? But what that API specifically looks at, it's typically not something that the platform engineer would probably look into.
So for me, it was at some point it became important. And the case was when we want to log predictions in such a way that it's unified across all the use cases. So like, for example, imagine that you have a model for, I don't know, current prediction. You send a request to the platform replies with the prediction, and you save these predictions. You save the incoming request and you have saved the response in a, let's say, some database, in some log storage. And you want to run some analytics on top of that. And in order to do that, you want the logs to be unified across all the use cases. So churn prediction use case, I don't know, lead scoring use case, all the other use cases should follow similar schema in order to be able to analyze this later and maybe do some monitoring, do some analytics. But yeah, this is maybe a specific one. So you don't always think about this until you need to do this. But sometimes, yeah, it's important.
I think it's a good point. I think I would imagine in that role you were part of the team building these models. Yes.
Yeah, I was kind of being a part of all the teams. So my role was to like overlook the entire process.
Okay.
I connect the platform team and the users of the team or of the platform.
Okay, yeah, makes a lot of sense, especially in that position. I think in that interface position.
Okay, well, we should be wrapping up, and maybe last question for you is: we talked a lot now about building platform, the skills we need, and I know that you have written a lot of stuff. And actually, in the questions we prepared, there were questions about stuff you wrote, but we never had a chance.
Never touched upon it. Too many things to talk about.
So maybe you can, recommend some further reading if you want to learn more. Could be from you or from other people. I mean, maybe there are already books about this stuff. Maybe there are good courses or I don't know, good videos, good talks about this topic.
Yeah. Well, I would, of course, as you said, there are some good books about MLOps and machine learning engineering. I think what's important to notice, MLOps is a term that I think not very well defined. For example, when I speak about MLOps, it's usually from a platform perspective. I'm thinking about ML platforms. For other people, it's very different. For them, machine learning operations is basically everything from deployment onwards. So that's also a bit with the books, right? There are some books, for example, Designing Machine Learning Systems is a very popular one. It's also a very good one, but it does not take very much the platform perspective, actually. It's really more around building that model. Nevertheless, it's a great book. I also like particularly Practical MLOps, also a book by Noah Gift and his co-author. And what I like about that one is that it is, well, the name says it, it's actually very practical. And that means also it's really going to show you how to build things on the 3 big cloud providers. And that, I believe, is a great asset to have. And that also brings me to my overall recommendation. Books are great, and well, but putting things to practice, building your pet projects is that what I really recommend. It's not, and I think that's also why I love DataTalks.Club, the MLOps Zoom camp specifically, because that's what you guys are doing. And that's really where you learn. And that's also not only where you learn, but also how you can showcase your skills to a future employer, for example. So it brings together a lot of these things. Don't get too stuck in books. Start building, what I would recommend. But that's also a bit the the type of learner that I am.
Yeah. Thank you, Simon. Thanks a lot, everyone, for joining us today. Thanks, Simon, for joining us today too, and share all your expertise. And yeah, that's all we have now. And yeah, enjoy the rest of your day and the rest of the week. And yeah, see you soon.
Thanks a lot.
Bye. Yeah. And now I will need to go outside, and it's so hot. I hope my brain does not melt.
Yeah.
Hopefully, we will still be able to talk after I